Lesson 4-3. So far today, we have a couple of ways to prove triangles congruent. We have SSS and SAS. Today we're going to be adding two more to that list, ASA and AAS. So you will need to know all of these theorems. So here's ASA. If two angles in the included side between them, so this should say included side between them, then the triangles are congruent. So write a congruent statement for the triangles that are congruent by ASA. So I see angle, side, angle, angle, side, angle, and then notice how this side is not included, so then this shape is not going to be in the mix. So we're looking at these two. So I'm going to go from a 0 marking to a 1 marking to a 2 marking. So triangle SUV is congruent to triangle N with 0 markings, E with 1 marking, and O with 2 markings. Try the bottom question. Again, remember to hit pause if the kids need more time to work. Here is the solution. This side is not included between the angles, so we throw out this triangle. Otherwise, we're matching angle 0 to angle 1 to angle 2, 0 to 1 to 2. So OGH is congruent to TCA. Here is our fourth postulate, AAS congruence theorem. Actually, it's a theorem. You must know two angles and a non-included side. Then the triangles are congruent. So notice how we just go angle, angle, so we go angle, skip a side, angle, then a side. So let's try a proof. Let's get our given information written down. And then I will look at our pictures for marking. So we know the angles are congruent, so M and K, and then we know the lines are parallel. So we have to prove the top triangle congruent to the bottom triangle. So is there anything that the picture gives us? Yep, you got it, reflexive. So WR is congruent to WR. Make sure it is a segment. And again, you guys said it, reflexive. So right now, we have a side and we have an angle. So our options for proving congruence are SSS, SAS, ASA, and AAS. So we know it's not going to be SSS. Not going to be that one. For it to be side, angle, side, I think we need another side in there. So let's look at what we haven't used yet. So why are they telling us the lines are parallel? So again, if I extend these lines, this line, and then here's my transversal, we get alternate interior angles. And we have to be specific when we're naming those. So I see angle MWR is congruent to angle WRK. And this is because the lines are parallel. That means that alternate interior angles are equal. So there is our second pair of angles. So now we have angle, angle, side. So triangle WMR is congruent to triangle RKW because of angle, angle, side. Hit pause if they need more time. Is it possible to prove the triangles are congruent? If so, state a postulate or theorem you would use. So our choices are SSS, SAS, ASA, and AAS. So right away I see vertical angle theorem. Double check parallel lines, there aren't any, there is no reflexive, so this would be a yes by the angle, angle, side. And then maybe I would mention vertical angle theorem in my explanation. Part B, I see reflexive. I don't see parallel lines, so I do not have alternate interior angles. We have no other information, so this is going to be a no. Try part C. So in part C, we have parallel lines, so we need to be careful. I see angle 1 and angle 3 are going to be congruent because of alternate interior angles. And then by that same reasoning, angle 4 and angle 2 are going to be congruent. So we use alternate interior angles twice. And then we can use reflexive to get that other missing side. So then we have angle, side, angle. Try these three. Here are the answers. Here is our next proof. Please get your givens written. All right, looking at this question, I do not see any given information, so that's why I took off those red angle markings. So I see the word bisect. We have to think about what a bisector is. So we're bisecting angle SRQ. So if we bisect an angle, that means we're splitting it in equal parts. So because of that step number 1, we get angle SRP congruent to angle PRQ. And how do we know that? Definition of angle bisector. Same thing is going to happen with our next step, except we bisect on top. So then we look at our triangles. I have an angle, and I have an angle, so I'm missing one more piece. So our step 5 is going to be that PR is congruent to PR, and that would be because of the reflexive property. So now we have our 3 pieces. I see an angle, a side, and an angle, so our 2 triangles are congruent.